Welcome to another video on SRID Cloud. In this video, I want to talk about a technology called Ceph for storage. Every computer has got a hard disk built in it. It can be a spinning disk or a solid state disk, or it can be NVMe disk, anything. But that is a local storage, and the operating system running on that computer will make use of it. But what if it's not sufficient, the size of the storage, or what if it has too much of storage on it? It's very efficient to combine the local storages of many computers together and form a cluster. And when you do that, the local storage is attached to each and every computer in the cluster can be optimized from usage perspective. And also it has got its own other benefits. So let's get started, and I want to show you some high-level description about storage in general, and then what is Ceph and what are its components. And then we are going to create a Ceph environment with a bunch of computers. So let's get started. There are two types of storages in computers. One is local storage, as I said earlier, the local storage that is connected to the computer itself. When you go and buy a computer, whether it's a desktop or a laptop or server, it comes with its own local storage. But storage is not limited to the local only. It can come from a remote storage. The storage arrays, which are meant only for storage purposes, contain several hundreds of storage canisters, and the storage can be derived from such a remote storage as well through SAN switches and so on. But in this video, let us focus only on this local storage. So as I said earlier, the local storage attached to each and every computer can be shared and it can be optimized. But how to do that? Several technologies emerged, and the latest one is the software-defined storage. Its main purpose is to enable the local storages to be combined together in the form of a cluster. And whichever virtual machine or computer want to use such a storage, or maybe carve a tiny portion of the clustered storage, then it has to become part of the cluster as well. So we're going to see how the whole thing is done. But in this slide, I also talked about the remote storage for reference only. The remote storage can be connected to a computer using either the TCP/IP, which is otherwise called iSCSI, or the fiber channel protocols. The SAN switches or Ethernet switches sit between the remote storage and the computer which consumes the storage. And also from usage perspective, the storages are combined in the form of a hierarchy called file storage, object storage, and block storage. And these are the examples of each and every one of them. So apart from this, there's also an InfiniBand storage technology for high performance computing. But in this video, let's focus on how to share local storage using Ceph technology. So what is Ceph? Ceph is a distributed storage technology. It uses the local storage attached to each and every computer in the form of a cluster, combined in the form of a cluster. And the technology is meant for scalable. You should be able to add additional computers with local storage so that the local storage can become part of the clustered storage. And the architecture has got administration and monitoring and the storage device itself. Let's take a look at this diagram to understand more. So here it is. See, the boxes in yellow are the computers. It can be physical computers or it can be virtual computers. It is also possible to represent these in the form of containers as well, but we shall see that later in another video. So for now, assume the admin, monitor, OSD 1, 2, and 3, and client are either virtual machines or physical computers, the bare metal computers. The OSD 1, 2, and 3 in this example have two disks attached to them. One of them is the boot disk. The operating system boots through that disk, and in this example they are of 20 gigabyte of size. And along with that, there is a second empty disk is also attached to each and every one of them, and I set the size of them are 30 gigabytes. So put together, our intention is to consume 90 gigabytes of storage across three OSD 1, 2, and 3 computers and form a clustered storage. So later on, a computer called client can also participate in the cluster and carve out, say, 5 gigabytes of storage out of 90 gigabytes for its own usage. Similarly, many clients can participate in this cluster. But the beauty of this approach is the client systems need not have to have the local storage. In the sense, for booting purposes, they need to have storage, but otherwise, they need not have to have local storage. They can derive storage out of these cluster. Other client computers can also provide storage, its own local storage, into the clustered storage as well. So Ceph allows to do that. So now I want to start showing you a procedure on how to install Ceph and how to set up a client system to consume the shared storage from the cluster. So here are my computers. These are this can be virtual machines or this can be physical computers. So first is the Ceph admin, and this acts like a control plane for the Ceph storage, and its IP address is mentioned there. It is static IP address. And I also have another computer called Ceph Monitor 1. As you must have guessed by now, I can have multiple monitors for scalability purposes, but in this example I have only one, and its IP address is also mentioned there. And there are three OSD, the object storage devices, which have the additional 30 gigabytes of storage in each. Their IP addresses are also mentioned here. And then finally, a Ceph client system, a separate VM or computer, and its IP address is also mentioned. So all these things are going to be part of the Ceph cluster. And finally, we're going to see how to carve a tiny portion of storage from a Ceph cluster for client purposes. Okay, let's get started. I am in my first computer, the Ceph admin computer. In this computer, I will add a new user called Ceph user using the user add command, and set its password as well. And then I will add that user to the sudoers file so that it can have the super user privileges. And then I will also disable the SE Linux by modifying the HC SE Linux config file, changing the SE Linux setting from enforcing to disabled. And then I shall also set the host name of these computers. So here it is. The host name file is set to appropriate value. And also I collected the IP addresses and host names of all other nodes, the monitor, the client, the OSD 1 and 2 and 3, and added them to the HC host file. So by doing this, I'm able to access all other nodes, the Mon 1, the client, and OSD 1 and 2 and 3, computers by their host names. And I repeated these steps in all nodes. Let us go to the monitor one file, monitor one computer, and maximize it, and its host name is set appropriately, and also the etc host file as well. And let's also look at the SLNX file here. And set the SLNX as disabled. So I repeated this on all other nodes as well. Now the next step is to create an SSH key on the Ceph admin and copy it over to all other nodes so that the admin can log in and access other nodes without passwords. Let's see how that is. Okay, so I am in the Ceph admin computer, and I'm logged in as Ceph user. If you are logged in with root ID or any other ID, switch over to Ceph user with the su command. And the first thing we are going to do is generate SSH key, and we're going to do that with SSH keygen command. I'm going to hit enter for all these values, so it's done. Now let's take a look at the SSH key that got generated. Here they are. The IDRSA private key and IDRSA pub, the public key. The public key will have to be copied over to all other nodes. And here is another verification from here. Since I have all these hosts defined here, I should be able to ping and access them without any IP address. For example, I should be able to ping on 1, it should work. Ping a client, it should work. Ping OSD 1, 2, and 3, they all should work. So now I'm going to add these nodes to the SSH configuration file before copying the keys over. So to do that, I shall open the .ssh config file. So here I have to add reference to all nodes. So let me do that. So this is how it is done. So in this file, the SSH configuration file, I basically add reference to all my nodes and the user with which I will be accessing them. Okay, so let me quit, and now I will set the permission for this configuration file that I just created with chmod command. So now I have to change, I have to basically copy the SSH key, pub key, to the other nodes. So how do I do that? Before that, I need to populate the known host file in the SSH. So how do I do that? Using this command, key scan OSD1, OSD2, OSD3, mon1 client, and append them over to, let's see if there's anything in the known host file. I don't think there is, the file exists, so let's check. Yeah, the file does not even exist. Okay, so SSH key scan OSD1, OSD2, OSD3, mon1 client, There they are. So let's take a look at this file, and it gets copied with the fingerprints, I guess. So now I'm going to copy the key from Ceph admin to all these nodes one by one. So sudo ssh copy id to OSD1. No identities found. Let's see what it is. I got that error because I did not specify the pub file as an identity. So here it is, sudo ssh copy id minus I, the pub file path, and then the OSD1. Now that went through fine. So let me continue. So now I need to enter the password for the OSD1 root, which is now it got added. So now I need to verify when I SSH into OSD1, I should be able to get in without any prompt for password. So let us try that. No, that seems to be not working. Okay, now I need to copy the SSH open the public key to all of the nodes. So let me do that with SSH copy ID. But before that, I want to make sure I'm logged in as Ceph user on the Ceph admin. So here is the command that I'm supposed to use. So SSH copy ID minus I, the IDRSA pub file, and then OSD2. So let me hit enter, and it's asking me for the password for the Ceph user on OSD2. Let me key it in, and that's it. So now to verify whether the Ceph admin, the Ceph user on Ceph admin can access OSD2 Ceph using Ceph user ID without any password. So let me try SSH OSD2. This should not prompt any passwords. It should directly take me into OSD2. There I am. So now let me exit, come back to Ceph admin, and I am Ceph user. Let me repeat this to other nodes as well. So OSD3. I'm prompting for the password. The password is not right. Okay, it went through. So let me try the mon one now, and then the client. Okay, done. So now all the SSH keys have been copied over. And the next step is for me to start the firewall on the Ceph admin. So let me do that. I need to log in as root for this. So I am logged in as root now, and I need to make sure the firewall dservice is running. So it's already running, so I don't have to do anything. I want to make sure it runs, but I need to add some ports to the firewall. So let's look at them. They are port 80, port 2003, and then a range of ports starting from, actually there are only two, 4505 and 4506. So let's do that. Firewall CMD zone public, add port 80, and this is TCP protocol, and make it permanent. Okay, done. Now I need to do the same thing for port 2003. Permanent, done. And similarly for the range 4505 to 4506, only 2 port numbers. Done. And I need to reload firewall, so firewall CMD reload. So the firewall is reloaded. And now I want to SSH into Mon1 and set up a slightly different firewall configuration there. So whatever we have done so far, it's only to the Ceph admin. So let me SSH Mon1. I'm in Mon1 now, and I want to make sure firewall this service is running. And here in the monitors I'm going to add port number 6789. So sudo firewall CMD zone equal to public, add port 6789, convenient number, TCP, and permanent. Done. So now I need to exit out of this and log into OSD1, 2, and 3 separately. I'm in OSD1. I want to make sure the system CTL is okay, it's up and running. So let me see what I can add here. Firewall CMD zone public, add port 6800 to 7300 TCP. Permanent. So all these ports have to be opened on the OSD 1, 2, and 3. So we're doing it for OSD 1 now. So all done. And I'm going to do the same thing for 2 and 3 as well. So let me come out of this OSD 1 and go to OSD 2. Let me copy paste this. Done. And let me go to OSD 3. The reason why I'm getting a password prompt is because I'm logging in as root. The passwordless SSH key exchange was done for Ceph user ID server, but right now I'm a root user. That's why I could have switched my user to Ceph user on Ceph admin and then SSH'd from there, but it's okay. Okay, let me paste this here as well. Okay, done. So the firewall configuration is now complete on Mon1 and then OSD 1, 2, and 3, and also on Ceph admin. So So that activity is now complete. Now the next step is to set up the Ceph cluster, and here is the Ceph admin. I'm logged in as a Ceph user, and now the first step is I'm going to install the EPEL, the extra packages Enterprise Linux on this one. I think it's already there, but let me try anyway for it to show how to install the EPEL. So this is how you install the EPEL release repository, and it's already there, so it's not doing anything different. So the next step is to enable the power tools, because we'll be using later on Ansible and all those things. So here it is. It's done. Now the way we are going to install the Ceph cluster is to download the Ceph Ansible repository from GitHub, and then use that to install everything we need to set up Ceph cluster. So to do that, we need to install Git. So let me do that. So this will install Git on this Ceph admin node. So let's wait for it to complete. It should be very quick. Okay, done. So now the next step is to clone the Ceph Ansible repository. So how to do that is git clone https github.com ceph ansible.git. Done. And now let me log in. Let me switch over to Ceph Ansible directory and look at all the branches. So there's several branches, and what we are interested is the stable branch, which is the latest stable branch is stable 5.0, and we are going to switch over to that one. So git check out stable 5.0. So now I am on stable 5.0 branch. So now I need to install all the requirements that are dependent. So to do that, I need the pip3, and to install pip3 I need to do this: sudo yum install python 3 pip. Sorry, python 3. Python 4 is not there yet. Okay, it's already there, so that's good news. And now I'm going to install. So there should be a file called requirements.txt. Let's take a look at that file. So all it has is the netaddr and also the Ansible specific version range out there. So to do this, I will do sudo pip3 install -r requirements.txt. So this is downloading Ansible 299 as required, and all other dependencies that go with it. So let's wait for it to complete. Should be very quick. There we go. And the next step, we would like to make sure the Ansible is in the user local bin. Let's look for it. There it is. So it's there, but we want to make sure this is in the path. Let me run Ansible anyway and then see if it's already in the path. It is already in the path. So that's good. Let me echo. So user local bin is already in the path, so we don't have to do anything else. And here is the Ansible version again. So 299 is the version. The next step is to set up the Ansible playbook. So this is how you can do it. We are in the Ceph Ansible cloned directory, and I'm going to copy a sample playbook file. It's under group wards all.yaml sample into the same directory all.yaml, and I'm going to edit the newly created file. The first thing is the Ceph release number, and that should be set to 15. And the next thing is the cluster name, and that should be called Ceph. So that is what it is. And then I want to set the names of the various groups. So let's start with mon group name, and it is set to mons, and then the OSDS group name is OSDS, and everything else. And then I need to set up the firewall configuration. We already configured the firewall on all our nodes, but let Ansible do it again. This is an option. Let me look for that. So configure firewall set to true. And then NTP, so we need to set up the NTP service as well. I don't see that here, but let me add those things. Sorry, NTP and NTP daemon type also set to Cronate. Let me save this thing for now. And then the Ceph packages. And Ceph package, Ceph origin should be set to repository. So as you can see, the explanation right above, you'll get the Ceph installed through a new repository. The other options are also mentioned over there. And then the Ceph repository should be set to community. And then the Ceph repository type Ceph repository type should be set to CDN. Let me save this real quick. And the Ceph stable release. And it should be set to Octopus. We're going to be installing Octopus version of Ceph. And then the monitor interface and Radar's gateway interface should be ENS33. So let me see where they are. Okay, there it is. And we're going to set it to ENS33. That is because pretty much on all our nodes, the names of the interface is ENS33. And we are not going to have two different networks here, one for public and one for private. We're going to have the same 192.168.182 range of a network for both. So there's no complication here. So let me go back to this file again. So ENS33 is a monitor interface, and the Radar's gateway interface that is also set to ENS33. And then we need to focus on the dashboard. So we need dashboard for Ceph. So dashboard enabled should also be set to true. And the dashboard protocol should be HTTP. And the dashboard admin user should be admin. So there's going to be a new Ceph user to be created. And then we need the password for the admin. So let me see if it's already there. There it is. So by default, we can set it to P @SSWO0RD. That's okay. We can leave it as is. And finally, the Grafana admin user. Here it is. And that is also admin, and the password, Grafana admin password, is also set to admin. So we can change this also to whatever we did for dashboard, Ceph dashboard P @CRD, just to keep things simple. Okay, and then that is it. The next step is to configure the OSDS YAML file. So for that, I'm going to copy an existing sample file, group where's OSDS sample to same directory, group vars OSDS.yaml. And now let me open this group vars OSDS YAML file. The first thing is a copy admin key should be set to true. Uncomment it and then set to true. So because we are going to have a distributed OSD nodes, the devices, and we already figured that the devices on all OSDs are going to be dev SDB. Where is the devices? Okay, so I'm going to uncomment this and comment this as well, only one. That's because if you remember the earlier part of this video, we looked at the lsblk command on all OSDs and ensured the newly added second disk on all these OSD VMs or computers were set to SDB, the dev SDB. And that's it for this file. And now we need to set up the inventory file. So this is playbook file, and we're going to have a file called hosts. So here, first of all, we need to define the user and password and so on. Okay, this is the first step, and user in our case is Ceph user. That is and become user is also Ceph user. I think this become user is root. Not sure, but let's see. So the next is the monitors, and we are going to use the mon1 as our monitor node. We have only one, and then I think similar for MDS nodes. So MDSS is also only one, and then we're going to have the RGW. Let me copy this 3 lines, and then okay, and then the OSDs. We have 3 OSD nodes in our case. Let us set them up here. They're all OSD 1 and 2 and 3. So OSD 1, 2 and 3. And finally the Grafana server is going to run on OSD 1. So if we want, we can have another node, but let's not do that. We will be using the OSD 1 for Grafana server as well. So this is it. And now one more thing before we can run the Ansible playbook is a site YAML file. So let's see what site.yaml file looks like. There's a sample here. So this is what it is, and then let's copy it over. So copy site.yaml sample as site.yaml. So we have host file and we have site YAML file. So now it's ready. We are ready to install Ansible playbook. -i host and then site.yaml. So this thing is going to run for a while. let it run. So here is the final status of install. Everything went through successfully. The monitor was set up, and then the OSD 1, 2, and 3 are all set up successfully, and the time taken to install each and every piece is also described here. So it was very quick. So now let's move on to the remainder of the steps. Now let's verify if everything is healthy, the Ceph is healthy. So to do that, I'm still on Ceph admin as Ceph user. I'm going to SSH into mon1, and then I'm going to run this Ceph -s, and there it is. Everything is healthy. The health status is health okay. All services are up and running, active, and the task status and data, everything is set up very nicely. And as you can see, as expected, 90 gig is the 3 disks we added to the OSD systems, and out of that 90 gig, 87 gig is now available for us to consume out of this storage cluster. The 3 gig is already used for management purposes. So now we are ready to consume this in our client system. So let's do that as a next step. Now let's configure a client system to consume this Ceph cluster. To do that, I am still on Ceph admin, and I'm logged in as Ceph user. I'm going to modify the host file, and I added a section called clients at the very end. Let me add a title for this, and client is the name of the node, client node. Let me make sure I can ping it. Yep, and I'm able to SSH to it. Let's see, there I am. So I'm able to SSH to it without password. So now let's proceed to the next step. I need to go to this group vars directory and copy client YAML.sample as clients.yaml. And let me look at this client.yaml file. I need to modify this. The user config is set to true, and then I'm going to uncomment the pools section as well. So there are 2 pools here, test1 and test2. And then OSD pool default pg num. So I need to uncomment these sections as well. Okay, so the test and the test2 pools are also uncommented. One more thing we need to do in the client YAML file is to create the keyring. So to do that, run this command and it produces a key that I have shown here. So after getting the key from the Python 2 output, add it to the keys section for both test and test 2 clients like this, and then run the Ansible playbook with this command. So this will automatically set up the key rings on the client side. So now let me run this Ansible playbook to enable client. Wait for this to complete. So here is the final output, and the client is now added to the list. And I could have done the whole thing in one shot with the client YAML file when I ran the playbook for the first time. So the whole thing was done in 2 steps. Monitor and OSDs were set up separately, and then client was set up separately, and we could have done the whole thing in one piece. So everything went through successfully, and now let's get on the client system and then see how we can consume the Ceph storage. So now we need to consume this cluster that we created. So let's see how it can be done. So I'm on Ceph admin, logged in as Ceph user. Who am I? Is Ceph user. So now I will SSH into the client system. Remember, we already set up this client system with Ceph on it already. So SSH client. So now the first step is to figure out whether this client system can see the pools that we created. Remember, test and test 2 were the pools we created. So now let's run this sudo OSD Ceph OSD ls pools. And it is showing there are about 9 pools, and the last 2 are the one that we created. So now let's create an image on one of the pools, say for example test. And so let me do that. Let me say my image 1, and let me create with size say 1 megabytes only to keep things simple, and then the pool is test. So this command will create an image under the pool test. So let me click enter. Done. So now let me see if the image got created. So for that, I'm going to execute this command, and there it is. There is a my image 1 with 1 megabytes. So now the next step is to activate the RBD kernel module. I'm not sure whether this is needed every time or it can be done only once, but it is needed. Make sure the RBD kernel module is loaded, and this command as well to fine-tune it. My image 1. Yeah, here is a command. So it is also done. And now we need to map this image to a block device through the RBD kernel module. So to do that, I'm going to say sudo RBD map, and my image 1 in the pool test. So this will do the mapping required into the kernel module. Done. And look at the device assigned to the block device assigned to it as dev rbd1. So this is the one that we will be mounting later on for the workload or application running on this client to access. But let's see if the mapping went through successfully or not. So let me run this. Show mapped. There it is. So under the pool test, the image my image 1 of 1 megabyte size is mapped to dev rbd1. So now we need to make file system on this. I'll be making a ext4 file system on this device. So let me do this again. So the dev rbd1 block device will be make file system with ext4. So to do that, I need to use the make file system command 1. There is a warning that this file system is too small for a journal because it's only 1 megabytes. So that's why. Otherwise, the file system got created in that. So now the next step is to create a directory under mnt to mount it. So let me do that. My disk 1. And then the next step is to mount this on that. Sudo mount dev rbd1 into mnt my disk 1. Done. So now we successfully carved 1 megabyte out of the 90 gigabyte Ceph shared storage, the cluster storage, and mounted it as a directory under the client system. So now let's try some command like df and make sure it shows up there. So there it is. The dev rbd1 is now mounted under mnt my disk 1. So let me go there, mnt my disk 1. So here it is. So I'm going to create a file here, test file. I think I need to use sudo test file. This is a test record, and then quit. So there it is. I'm able to write a file and I'm able to read a file and things like that. So we successfully created an image and mounted it under the client system for any application or workload to use. So this is how you install Ceph and configure it and then even consume it. And I hope you enjoyed this video, and I'll be producing a lot more videos on all these technologies, and I will see you all in another video. So bye for now.